Hello my dear class 12 science students. So today we are going to start a new chapter under unit number 1, electrostatics, and the name of the chapter that we are going to start is electric potential. This is the third chapter in electrostatics, okay, after Gauss theorem. So this is also an important chapter, okay, and basically in this chapter we focus on what is electric potential, what is potential difference, okay, and especially we calculate the potential due to point charge, potential due to electric dipole, and most important from this chapter we discuss about electric potential energy for the system of charges. Okay, now to start with this chapter, so let me just do the introduction of this chapter. Okay, now basically we have we understood what is electric field. Now electric field basically we understood as a space or region where a charge placed at that point, at any point in the space, experience a what? Force. And that charge is basically what charge? Test charge. Okay. Now electric field can be produced by a charge, a group of point charge, or continuous symmetrically distributed charges. But the electric field around a charge, basically we call this charge as what? A source charge. And this electric field produced by a source charge can be described by two ways. Okay, described by what ways? Two ways. Now one is by the intensity of electric field, and this is also called the strength of electric field. Number one is what? The intensity of electric field, also called the strength of electric field, and this is basically a what quantity? Vector quantity. But there is another term that can also express electric field, and this is expressed by the term called electrostatic potential, also called electric potential. So electric field is not only expressed by the strength of electric field or the intensity of electric field, which is a vector quantity, but it is also expressed by the electric potential or electrostatic potential, which is a what quantity? Scalar quantity. That means there are two terms that characterize electric field. One is intensity of electric field, another is the what is it called? Electrostatic or electric potential. Now both electric field intensity and electric potential are the characteristics. Both are the characteristics of what? Like characteristic property of any point in what field? Electric field. Okay, in what field? Electric field. And means when we define electric field, there must be the strength in which the electric field can be measured, and that is measured by intensity of electric field. And there is another term that we can even define and measure in electric field, that is electric potential. Now in today's class we discuss in details about what is electric potential and basically the potential difference. So let's start with the concept of electric potential and potential difference. First of all, let me explain what is potential difference, then we understand electric potential. Okay, so for that let me take a charge. You can see the charge that is plus Q charge at O, and this charge is also called a point charge, and also called as what charge? Source charge. Okay, and this is the only one charge which is located at O. Okay, and that's why this charge is also known as the isolated point charge. What charge? Isolated point charge, and that you are placing at point O. Okay, and the medium in which it is placing what? Air or vacuum. Now you know, as for the concept that we have learned, if a charge is placed this way, then what is produced by this charge? The field. There is a field or region which is created by this charge. Okay, why? Because whenever you keep a test charge at any point in the region, this test charge experience the force. Okay, test charge experience the force. Okay, now definitely this charge produces the field in this field or space which created the space or field is created by this charge. Okay, so whenever we keep a test charge at any point, it experiences the what? Force. It experiences the what? Force. Now for that, let me take 2 points. You can see there are 2 points we have taken. One is there are 2 points. One is A, another is what? B. Okay, there are A, another is what? B. So when at point A and B are the point which are taking in the field, that means this test charge, this source charge can create the field, that is, it creates the space in the surrounding space. Okay, so when we take 2 points, one is A, another is B. Okay, so these are the 2 points where the test charge can be placed, so that if this test charge experience the force, then there is a what? Field. So let me consider these are the 2 points where the test charge can be placed. Okay, and it experience the force. Now let me just take when we take a test charge, let me take a what charge? Test charge, that is Q naught, and that is already at A. Suppose the test charge is already located at what? A. So definitely what happened? This test charge explains the force. If this test charge explains the force, means there is a field produced by this test charge at point A. Okay. Now if the same test charge, if I moved from A to another point, say B, you have to do the work. You have to do the what? Work. And you have to do the work against the what force? Repulsive force. Against the what force? Repulsive force. Okay. Because your repulsive force acting this side. So when the force acting, repulsive force acting this side, you are taking the test charge from A to B. Definitely you have to do the work against the repulsive force. So work can be done to move the test charge from A to B, and that work done I consider as WAB. So what is WAB? WAB is the work has been done in moving a test charge against the what force? Repulsive force. Okay, and that test charge is placed from A to B. So definitely you have to do the work. So from this we can define electric potential difference. So what is electric potential difference? You can see electric potential difference is defined as the potential difference is defined as the amount of work done. Defined as the amount of work done to move the test charge from one point to another point in an what field? Electric field. So if you look at the diagram, A is a point where the field is there created by the source charge, and B is also the point where the field is created by the what charge? Source charge. Now we are taking the test charge from A to B, from one point to another point in an electric field. You have to do the work, and that work done in moving a unit test charge, positive test charge, from one point to another point in an electric field is defined as potential difference between 2 points. Is defined as potential difference between what point? 2 points. So potential difference between 2 points in an electric field is defined as the amount of work done in moving a test charge from one point to another point, okay, in an electrostatic field or electric field. So mathematically we can express by the relation B equals to BA minus BB, BB minus BA, and that is equals to WAB by Q naught. So test charge is Q naught. Your work done to move the test charge from A to B is WAB. So definitely there is a potential difference between A and B and A, and that potential difference is given by B equals to BB minus BA equals to WAB by Q naught. So in this diagram, if you see the potential difference between 2 points, one is between A and another is B, is given as potential difference between 2 points. So in a simple manner, potential difference between any 2 points in electric field is measured by this relation. Okay, but one thing I want to request out here is that when we take a test charge, the test charge should be very, very small, okay, so that it cannot disturb the electric field produced by the what charge? Source charge. Okay, so cannot be disturbed the electric field produced by the what charge? Source charge. That's why this is the definition of potential difference between 2 points.